Alrighty, everyone. This is a pretty quick video. I say that, and then hopefully it's not super long for you. On how to deal with what are called limits at infinity. Okay, so what I'm going to show you right now are limits at. Okay? Now, limits at infinity are 100% dealing with end behavior. And the good news is you know everything there is to know about end behavior because the only two functions we talked about were polynomials, and those have end behavior of up, up, down, 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 up, and up, down. And then we also talked about rational functions, and they could have all of these end behaviors, right? Or a horizontal asymptote. Okay? And that's basically it. There's one other function I want to show you, and that's the exponential function. And I'll talk about that briefly. But in essence, you already know all of the answers for limits to infinity because you know the end behavior rules of polynomials and rational functions. That's why we reviewed it at the beginning of the year. Okay? So, if you see the question, what is the limit as x approaches infinity of a function, what they're asking for you from you is for the right end behavior of the function. If you see the question, what is the limit as x approaches negative infinity of a function, what they're asking for is the left end behavior of the function. Okay? So let's take something that you know really, really well. All right, and let's look at the limit as x approaches infinity of, let's do x, and then we'll do the limit as x approaches negative infinity of the same function. Okay, now we know that this is a positive odd, and positive odd graphs go down, up. So as I go to infinity, this function goes up to infinity. And as I go to negative infinity, that's the left-hand side, we know that this graph goes down, so this goes to negative infinity. So that's as easy as it gets if you have a polynomial function. Okay? Now, another function that you might have to look at is a rational function. And we've done those. All right, so let me just give you an example. So let's say that I have the limit as x goes to infinity, and let's do 5x squared over 3x squared. Well, this is a rational function, and we're being asked for the end behavior, right? Because we want to know what's happening as we get close to infinity. Well, if I look at the degrees, they're equal. So I know that this thing has a horizontal asymptote at y equals leading coefficient over leading coefficient. So the limit as x goes to infinity of this rational function is simply 5/3. And the answer would be the same since it has a horizontal asymptote. The answer would be the same if we were going to negative infinity. This would just be 5/3. Now, one rule that I really need you to you don't really have to memorize it because I think you pretty much know it. Let's take a look at this one. The limit as x goes to infinity of something like 1 over x. Okay? Well, you can think about this. It's a rational function, right? And rational functions, their end behavior depends on whether or not they have a horizontal asymptote. And I know that this has a horizontal asymptote at y equals 0, right? So that means the limit as x goes to infinity of 1 over x would be 0. Now, the other way I want you to think about this is a fraction where the numerator is 1 and the denominator is getting huge, right? It's getting big really fast. So you have one thing and you're dividing it by a huge number, it's going to go to 0. The same would be true if you had the limit as x goes to negative infinity of 1 over x, right? this is still going to 0. All right, because even the denominator is getting a huge negative, right? It's getting really big, but it's getting negative. It's still going to 0. These are two that you just want to kind of memorize, because if you see a function that looks like this, all right, this will actually help out. So I'll show you what I mean. So let's take a look at a function that looks like this. The limit as x goes to infinity, and I'm just going to make some stuff up here. 15x to the fourth plus 1 over x squared plus 1 over x. Yeah, that should be good. All right, so what you can do here is you just take these limits all separately. So you can say this is the limit as x goes to infinity of 15x to the fourth plus, and I'm just splitting this all up, the limit as x goes to infinity of 1 over x squared plus the limit as x goes to infinity of 1 over x. Now this is one of those rules we talked about right at the very beginning of limits. Remember, I told you that was eventually going to be important, and here it is, okay? So what you can do is you can just take each of these limits separately. Well, for this one, this is a positive even, so I know it has end behavior of up, right? Well, I want to know what's happening at infinity, so that's the right-hand side. So this limit right here is just infinity. Plus, and then if we look at this guy, well, if I put a huge number in the denominator, I have 1 divided by a huge number. So this is 0, right? Plus that has a horizontal asymptote at 0. And then same thing here. If I have 1 over a huge number, I'm going to 0. Well, infinity plus 0 is just simply infinity. Okay? So that's a pretty cool rule to kind of keep in mind. It's a good rule to use, obviously. And you kind of just have to, make use of it a whole bunch. All right. So this is a good rule to know. The answer for this particular one would have been the same if I was going to negative infinity, and that's because this end behavior right here is up. But if you change this to an odd exponent, then things are a little bit different. Okay, and you can see that when you practice some of the problems that you'll be doing. Okay, so you probably make some mistakes on those, and that's totally fine. There's one other function that I want to look at, and it's not something that we've dealt a lot with in the past, and that's called the exponential function. Because the end behavior of an exponential is a little bit more difficult to work with. So basically, the exponential function is just y equals b to the x. Okay? And an exponential function can look two ways. One is exponential growth. And that's the one we'll deal with first. Okay? So the graph I'm going to draw you right now is the graph that you would get if b is greater than 1. So if b is greater than 1, this is the graph that you'll get. Okay? And I need you to remember that this has a horizontal asymptote at y equals 0. So if you look at the end behavior of this graph, it's probably a good idea to pause right now so you can draw this. But if you look at the end behavior of this graph, you would say that as x approaches infinity, so this way, you can see that y is going up. So y is going to infinity. And if you look to the left, as x goes to negative infinity, y is actually going to the horizontal asymptote 0. That's the case if b is greater than 1, because what you have here is exponential growth. Now, if 0 is less than b is less than 1, so this is not b is negative, this is if b is between 0 and 1, so like 1/2 or 2/3, 5/6, etc. If that happens, what you have is exponential decay. And the graph actually goes the opposite way. but still the x-axis is a horizontal asymptote. Okay, so in this case, you would have as x goes to infinity, y goes to 0, and as x goes to negative infinity, y goes to infinity. Okay, so might be a good time to pause the video and write some of that down. I'll keep going right here, and I won't explain anything. I'll just put a couple of examples down. So while you're copying that, I'll write a few examples here. Let's see. So all you have to do in these is, and actually I just wrote the same exact problem twice. Negative infinity. What you have to do in these, so I'll do like a step 1, step 2 here. When you have an exponential function, the first thing that you should do is look at b. And is b greater than 1, or is b between 0 and 1? Because then that's going to tell you which way your graph is. And then what I would quickly do on your test is either just go like that or go like that, you know. And then step 2, are you going to infinity or negative infinity? That's kind of the next question. Okay, so if I look at this one, I know that b, which is 2, is greater than 1. So that means I have this graph here. And they're asking me what's happening as I go to infinity, which is the right side. So I know this answer is infinity. You can also kind of think of it as I'm putting a really big number in for x. So I'm going to take 2 to a huge power. So 2 times 2 times 2 times 2, like forever, is going to be a really big number. Okay, in this one, same thing. If I look at b, it's between 0 and 1. So it's this graph. And I'm being asked what's happening as I go to infinity, so the right-hand side. And if I look at the graph, I can see that I'm going to 0. Okay. And then in this one, it's basically the same question, only it's asking for the left end behavior. So if I look at the left-hand side, this graph is going up forever. So it's going to positive infinity. So with these, there's really not a lot of math going on. Most of it is just, kind of looking at the situation and determining what's going on. And it's really just 110% end behavior stuff. Okay? So I'll give you a couple of practice problems to work on. Don't worry about this for the test next week. So we're going to take a test on Thursday, assuming everything goes okay on Tuesday when we go over the review sheet that you did for me. If things don't go well on Tuesday, I hope that they do. But if it's super bad, then, we can obviously move the test a day. I didn't anticipate on being out, obviously, because my computer's sitting on my desk, if you want to look over there right now. And I'm working with some old equipment here that I'm not super good at using. So, I will be back as soon as possible, and, we'll kind of just keep plugging along, all right? So do your best with the practice problems. Like I said, you can only do the best you can, and we'll definitely go over those on Tuesday. But first, we'll go over the review sheet. And if I can, I'll try to get you answers to that review sheet on Friday, if I can. Okay, I can't promise it. I'll do my best because that's all obviously at school too. So I'll do my best to get those answers out to you. But other than that, send me an email if you're in major distress, and we'll deal with it. Okay? So I hope you have a good day. Do your best on the practice problems, and I'll see you soon.